Remember we discussed that in RCBD experiment that every value is very essential. Every value is compulsory. So that is why when we have an experimental unit lost, for example, so that we cannot compute the data, then we count that value as a missing value. So in such a situation, say for example, if it was just one experimental unit that is lost, in such a situation, you will see that your catalog of data will not be complete. We'll have just one missing, all right? Now, how do we go about this? Sometimes in RCBD, we don't neglect, usually in RCBD, we don't neglect that missing value. What we try to do is use a set of formulas to estimate the missing value. Now, the missing value that has been estimated does not necessarily mean that is not necessarily correct, but it is going to be close to that. It's going to be close to that actual value that was supposed to be there. But the missing value is not necessarily always correct, and this is the reason why even after estimating the missing value, we have to give we have to solve for the correction of bias, because we assume that since it cannot be exactly correct, then there has been some bias in that computation. I'll repeat that. I said that the missing value that we have estimated, remember, is an estimation. So it is not always exact. In fact, it will not be exactly correct. It will not be exactly the value that is supposed to be there. When I show you the formula, you see the way it is combined. It is a way to just estimate the value considering a number of factors, like considering the values in the values that have been in that block or in the same treatment as that missing observation. All right, so we now try to use that same thing to estimate that missing value. So because it is not likely to be exactly correct, then we have to correct the bias. All right, so the first formula that you have to master, is the formula for the missing value. Missing value is given by m is equal to t, capital T, minus plus b, capital B, minus s, all over t minus 1 and b minus 1, or b minus 1, either way you put it. Alright, now what is this saying? It is saying that the number of treatments that you have in your observation times the treatment. Now look, it's just like walking towards it's just like an average. Look at it. We are multiplying how many treatments we have by the sum of the treatment. This big T represents the sum of treatments in the same treatment series as the missing value. So for example, if we have our catalog like this, and our missing value is here, and this is the treatment. So this big T will represent the treatments, the sum of the treatments that are in this treatment catalog here. The sum of these other treatments will be the T, and the block will be the sum of these guys here. Alright, so then we are now, after adding, we are now subtracting the total sum of, the grand total from that multiplication and addition. So do you see that it's just a way of estimating? Alright, then you now divide by the degrees of freedom error. Remember that t minus 1, b minus 1 thing, right? So that is how to calculate for the missing value. Then how do we calculate for the correction for bias, or bias correction, or whatever? It's just called correction for bias. Now we said that it is not possible that we get the exact value that was missing. So we want to try to correct the possible bias in the possible bias in our in what we have suggested as the missing value. So what we do is we use this formula actually, that is b minus t minus 1 then m all squared over our degree of freedom total. So t into bracket t minus 1. You see that? So it is very it's quite simple. You have to just master this formula. You see, we are just trying to estimate a value here, and then because the value might not be exactly correct, then we now correct the possible bias in using this. Now, take note that we only correct this bias on the total sum of squares and the treatment sum of squares. Then you will ask, why do we not correct, because it's in RCBD, why do we not correct the bias in the block? It is because our interest is not in the block. That's the first reason. Our interest is not in the block. And secondly, the block is already variable enough. We know that there is always going to be a variability, because of course, why is there a block? A block is because of the blocking is because is as a result of heterogeneity in your experimental unit. So that is already a variable. That is already a variability. So, but we're interested in the treatment because there might be a bias in the treatment. Because the treatment value, when I'm applying the same treatment to a particular experimental unit, what I expect is the same result. So that is why we have to correct the bias in only this sum of squares total and the sum of squares treatment. And how do we go about that? After subtracting the correction factor from the sum of squares treatment, we still subtract this bias from SS total and SS treatment, and that's all. We still follow the same protocol. We go by solving the correction factor. I hope you mastered the system of the calculation. See, that is the major thing you have to master: the system of the calculation. First, calculate the CF, then SS total, all the SS. We have SS for RCBD. We have SS total, SS treatment, SS block, and SS error. So the same, all of these SS will have their own DFs, right? So we have DF total, DF treatment, DF block, and DF error. Then some of these we have their own MS by dividing this by this. So we don't need MS for total, we only need MS for treatment and error here. So we do MS, treatment, and MS, error. Alright, so that is the sequence. Then we now do variance ratio of both of this. We do variance ratio and get our FK. So this is the system of calculation that is applicable here as well. But the difference is this: because of bias in an estimation, we say we will subtract our z from this, from SS total. We will subtract our z from SS treatment, but not SS block. I've told you, because our interest is not in the block, and not SS error. So we subtract z from only what? SS total and SS treatment. Alright, I hope that is clear. Now let's take a question from our question what? Question archive, or whatever it's called. Let us now answer this question. Now the question is about the dry weight of aquatic weed in kilogram per hectare from the ponds used for herbicide treatments or herbicide experiments. So these are the herbicides, which are the treatments, and then the blocks. All right. So we can see here that there is a missing value. M represents a missing value. There is a missing value here due to who knows. So just we find out that there is a data here that is not present. All right. So how do we go about solving that? I've told you it's very simple. All you need to do is write the formula for missing value first. So we said that the formula for missing value was what? T, capital T, plus small b, capital B, minus big S, over T minus 1, degree of freedom error, B minus 1. Alright. So we've gotten this. Now listen carefully. Very simply, we will now calculate our big T. So let's go to the treatment. On that, on the treatment value, on the for that missing value row. Alright. So this is the row of the missing value, and this is the treatment row. So all we have to do is calculate this plus this, and we are going to get 532. So it means that our big T is equal to what? 532. Our small t is going to be, how many treatments have we? 1, 2, 3, 4, 5. 5 treatments. Then our small b is going to be, how many blocks have we? 1, 2, 3 blocks. You see it is indicated there. So we have 3 blocks. Then our big B is going to be the sum of the guys in the same block as the missing value. So let's calculate this plus this plus this plus this. So that is going to give us around 1135. Let me confirm that. 1135. So yes, that is 1135. Actually, because I have solved this before, so I'm just imputing the values. So by yourself now, you calculate this, the sum of the blocks, put the answer here. Calculate the sum of this third block, put the answer here. Calculate the sum of the last treatment, calculate the sum, put it here. Calculate the sum, put it here. Calculate the sum, put it there. Now, but the grand total, when you add up everything, that is the addition of all the blocks and the addition of all the treatments, you are going to get 3971. But keep in mind that this 3971 is only the value, the grand total, before the missing value has been estimated. After the missing value has been estimated, we then change the grand total, because of course there will be a value here now. But this is a tentative or a temporary missing value for the fact that the missing value, temporary grand total when the missing value has not been estimated. After the estimation of the missing value, this guy is going to change. Alright, so let's estimate the missing value. Okay, the sum of blocks now, we said was 1135, 1135. Then our S, which is the sum, the grand total, before the estimation of the missing value, that's 3971. Alright, so let's impute all of those inside of our formula. So we have that M will be equal to small t is going to be 5 times big T, that is 532, plus small b, which is 3 times this, 3 into bracket 1135, and minus biggest, which is 3971. Notice what they are trying to do basically is that they are trying to look at these values here, 690, 160, 80, the consistency of the value in the blocks, and the consistency of the values, especially in the treatments. And that is why we'll be subtracting the z value from only the treatment, because at the end of the day, you are going to notice that the values that we will get for our treatment and the value that we'll get for our missing value will be close to these values in the treatment. That is the very important thing about it that you should note. The value that we should get in our missing value should be similar to the range of values that are consistent with the values in that treatment set. So, and that is why we are using such formula as this. That is why when we'll be correcting even in the treatment alone. That is the correction of bias. So, the treatment is very essential. Look at the range of values in the treatment, and that is what will tell you to be able to know whether, to be able to know if your answer is correct. So you see that there is a wide disparity between the values in the blocks. Look at 690, 80, 205, 160. So the disparity is much. But in the treatment, your answer should lie within this use range as well. That is how to know that you're correct. Alright. So because we are just trying to adjust the value towards just estimate a value that is, that should be there. So we have t, which is 5 minus 1, and b, which is 3 minus 1. And n is therefore going to give us. So we arrive at 261.75. So we have 261.75. 261.75. So this is where the calculation will go. Alright, then the next thing, please take note, it's very simple. The next thing after the n value, the missing value, this is an estimate of the missing value. Remember I told you that you are going to get something that is close to the range of values that are in that treatment. Look at it. 261, 261. Look at it, we have 242, 290 here. And if you notice, so far, the value here has always been greater than the value in the middle and greater than the value here. So you see 290 is greater than this, and this guy is greater than the value here. So and our value is also greater than this. So our value is nearly correct. As you look at this here, this is 160 here. 180 is greater than it, but it is greater than the one in the middle. So our here 80 is greater than this, but 89 is greater than 80. 205 is greater than okay, except here anyways. But our value has been consistent in a way with the series, that it is greater than here and it is less than here. 261 is a nearly correct value, but it doesn't mean that there's no degree of incorrectness there or bias, which we call bias. So we have to really work out that bias. And how do we do that? The formula we use is z is equal to b minus open bracket small t minus 1 close bracket m squared. Now, please don't follow the formula in the textbook uses a capital T, and that is not very correct. It's supposed to be small t. That is a typo. Over t minus, t bracket t minus 1. What is that called? The degree of freedom. I think degree of freedom total. So our b is still the b we use there, which will be 1135 minus small t, that is 5 minus 1, close bracket m, everything squared, m, which is our estimated missing value, all squared, right, all over t, which is 5 into bracket 5 minus 1. Alright, so that we'll have 1135 minus 4 times 261.75 all squared all over 5 into bracket 4, which is 20. Because 1135 minus 4 times this. 4 times 261.75. 75. 1047 over 20, right? So when you subtract it, what do we have? We got 387.2. 387.2. Alright, please make sure to take note of this square. It is very likely to be forgotten, so make sure to take note of it. Make sure you square your answer here before dividing. Alright, so then we go on to solving the normal series of computation. So our name is what? The name of the design is what? The Randomized Complete Block Design with missing value. Now, this is not necessary. Whether you write with missing value doesn't change anything. So, with missing value. Alright? So, then the model is still the same, which is what? Yij is equal to mu plus what? Beta I, treatment I plus, that is tau I plus bj plus epsilon I Alright, then we now start our correction factor. Okay, before we start, we have to re-estimate, we solve for this guy. So what do? We simply come here and add the new missing value that we have derived. So we add it. So please listen up. As here, you will replot your table. I'm not replotting now because of time. I just want to impute the values again. Please help me get all these values out. The first one for the treatment first. So this we just come here and write that 261.75. 261.75 is the new. So we will simply add that 261.75. We'll add it to our value. We have 2, 3, 1, 2, 1, 4. So we're going to have 4232.75. 4232.75. So what will change? This will also change. Why? Because we have added 261. So 532 plus 261.75. This will also change. That is 1135 plus 261.75. Notice the way I am doing it. I did not alter any other thing. I am altering only the sum of the treatment and the sum of the blocks. Alright? So that is the block in the same guide. Yeah? So what do we have? That will be 397. So that will be 793.75. Alright? And for here, we'll have 6931. That will be 0.75. That will be 1396. 1396.75. Alright. So our value has been altered here and here like that. Okay, so we now go on to solving calculating the correction factor, which is grand total all squared over n. And that would be what? 4232.75 all squared over n, which is our n is 3 by 5, that's 15, equals, alright, let's solve that. So the CF, we computed to be this over this, and we got 190, that's 1,194,411.504. You can approximate it 2 deeply, that will be 0.50. Then next, just the normal order. We go through the SS total, then SS treatment, then SS block, then SS error. That is the normal way of solving RCBD. So we just go through the normal steps. The only difference now is that we are subtracting Z. Alright, so 690 squared plus. Now take note of the method I am using to compute my values. It will take me more time to begin to write 690 squared plus 290 squared plus all of that to fill that up in my book. It's going to take me too much time. So what I simply do is I take 690 squared, I take it in this order. 690 squared plus this plus this plus this, dot 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 plus the last one here, that is plus 300 squared. Then I will now compute the values of those ones. This squared to give me this squared to give me this squared to give me this, plus dot 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 rather, plus this squared, 300 squared, give me 90k, 900k or 90k, whatever. So then minus correction factor minus z. Alright? Then we have this minus correction factor, then minus z. And we have this. Alright, the next one is the SS treatment. The same way, the same approach, you square your treatments. In this case, this and this and this and this and this. You square them and we subtract the correction factor. But one more thing, we subtract the bias for correction. So, or correction for bias rather. So we square this and then we get that. So make sure you're also doing it as well. We get 603,618.65. Alright, so the next thing we are going to calculate is the SS block. Now take note of the fact that we missed out something. Take note of the fact that we are supposed to divide by the number of replicates of the treatment. So it should be over B. So you should not forget the RCBD process. Your sum of treatment is equal to, sum of squares of treatment is summation T squared over B, because this treatment appears in block number of times. So 1, 2, 3. So it's supposed to be over 3, and we forgot to put that in. So this would be all over 3. Then we now have our values again. I'm going to recompute that. So the answer is still 603,618.65. It's actually because I have computed that before. So you divide by 3, it means that out is the formula. You divide by 3, which is the number of replicates for the treatment. And the number of replicates for treatment in RCBD is the number of blocks. While the number of replicates for block is going to be number of treatment. The blocks are repeated treatment number of times. Alright. So we have, I'm supposed to send to brush videos. So we have, SS block is going to be summation of our blocks squared over, the block is represented by beta, alright, over number of treatment, because the replicate for block is number of treatments, minus CF. Now remember I said we are not going to subtract our Z. Why? Because the blocks are not our, that is not our focus. So we remove that. We compute the block normally, so that we have our blocks. I've cleaned that out, but I think we have. So our SS block, the formula is summation B squared, our block squared, that is the block squared, the sum of the summation of all the block guys, then we square it over treatment. Remember that treatment will appear, the blocks will appear in number of treatments times, minus CF. All that thing is clear, that the block will appear number of treatment times. Is it clear?
So me?
Yeah.
No. I know the...
You know that the block is here, like the block 1. So it will appear in treatment number of times. These are the treatment. So block is appearing 1, 2, 3, 4. Do you get it? So the replicate for the block is the number of treatment, while the replicate for the treatment is the number of block. So like this treatment is appearing 1, 2, 3 times. It's applied 1, 2, 3 times. So that's what it means. So that is and then we do that, we get this. And our SS error is going to be SS total minus SS treatment and minus SS block, the normal way. Then after calculating all our SS, what do we say we calculate? It's our DFs. So our DF total first is going to be what? 15 minus 1, that is n minus 1, which is 15 minus 1, and that is what? 14. Then DF treatment is going to be what? Treatment minus 1. How many treatments have we? 5. So 5 minus 1 equals 4. Our DF block is going to be, how many blocks have we? 3. So that is B minus 1. That is equal to 3 minus 1, and that is 2. So that our DF error is basically this times this, and that is 8. But if you don't know what that means, we will just say it is DF total minus DF treatment minus DF block. So and that gives us 14 minus 4 minus 2 equals 8. So look at that, 4 times 2 will give us 8. Alright, so after calculating our DFs, we'll now go to our mean squares. Our mean squares that we need here are the mean squares for treatment and the mean squares for error. Alright, just like in CRD. MS treatment is going to be SS treatment over DF treatment. And our SS treatment was 603,618.65 all over. DF treatment was 4. Let me complete this. 6061. Then MS error is our SS error over the DF error. 603 618.65 divided by 4. So our yes, 0.65. Our SS error was going to be 7790.1 all over. DF error was 8. What's the answer? 150 904.66. Are we? Yeah. Okay. So then our SS error is what? So 7790.1 divided by 8 is going to give you what? 973.76. All right. So the next thing we calculate is, now if you want to calculate your MS for block, there is no problem, but since it's not needed, I will not be calculating it in the video. So the next thing is, we now calculate our variance ratio before we plot our table, or another table. So our variance ratio, which is F sub cars, is equal to MS treatment over MS error, right? So our variance ratio is going to be MS treatment over MS error. But it appears to be that there is a mistake here. Our DF error is not going to be this times this. You see, because there is a bias. Remember the way I explained the fact that in DF is if you have 5 friends and you want to share something amongst yourself, you want to compare something amongst yourself. So and you have a number of things that you want to compare. You have how many number of people to give it to share around? You have 4 people. So the same way here, what we do is, because there is one bias, we will subtract. So in the first case, you subtract only yourself and from the group. But in this case, because there is a bias, we will subtract ourselves and another person in the group, so that the number of times I have to share that thing around, I have to compare that thing around, will be 3. So here we're supposed to subtract. It's supposed to be instead of just this times this, it will be also be subtracted. 1 will be subtracted from it, so that we have 14 minus this, then minus 1 again, and that will give us 7. Then the DF total changes to n minus 2, and that will be 13. All right, please let me compute this now. 7 in that.
7. Okay.
In 7.
1.
That is what? 1. 0.87, like this. 112.87. All right. So that is our MS error. So we now go to our F. Please don't make that mistake that I made. We said DF total here. In case of missing value, this is only peculiar to missing values. That your DF total is going to be n minus 2, and your DF error is going to be your DF treatment times block minus 1. So you're going to subtract 1 because of the bias. Alright, and so that when you add it all up, you're going to get the DF total. This was the 6 plus 7, that is 13. So make sure not to make the mistake of just doing it the normal way. A missing value, you subtract one from the total and from the error. So the MS treatment is going to be the F car is going to be MS treatment, which is 150904. Please let me complete this. 0.66 all over 1112.87 equals 135.60. Alright, so then the next thing we do is we plot our Anova table. So you can of course go and check for the this thing immediately, for the F tab immediately. So we have treatment, block and error, then we have total. So that here will be SS, here will be DF, here will be, you can put DF first, okay, it's usually DF first, right? DF first, then SS, then NS. Either way you do it, you are correct, whether SS first or DF first. The major thing is you are dividing this guy by this guy in our F tab. So what's our F tab? Please let me check the F tab. Let me check from the table. How do you check the F tab? For the F tab, you will check for error of 7 under the treatment. You know the treatment is the most important thing here. So the treatment is 4. So you check for 7 under 4 on the F distribution table. So that's what's your F tab? Okay, so total is here we got 13, and SS treatment, I guess this is also bigger than this. MS, let's make 4.12. F tab. 4.12. Yeah. So F tab. For F tab we got 4.12. Alright, so SS treatment we had, what was SS treatment? 603618, right? 0.65, right? Then block 8012.61 and error 7790.1. Then the total, please, what is the total? Okay, 12619421136. In our MS, for the treatment we got 150904.66, and for the error we got 1112.87. Alright, so then our F count was 135.60. Seeing a value like this already, you even know that F cow will be greater than F tab. So from here, we know that F sub cow is greater than F sub tab. So what does that mean? Since F cow is greater than F tab, what do? We accept what? The alternative hypothesis. We accept the alternative hypothesis and reject the null hypothesis, because of course there is a very, very significant difference. All right, and so if you are now asked to check for where is the significant difference, in my opinion, seeing this value alone should tell us that the treatments are very, very different from each other. So all of them have significant differences. But if you carry out your post-hoc test, you use to get that. But your post-hoc test for this guy, for missing value, you also have to correct the bias. Because if, for example, if you want to use LSD, your formula will no longer be just T alpha over 2 comma df error, then square root of 2 times MSE over R. You would have to add the bias, and the bias is with the formula. I've actually forgotten the formula. Let me check on that. So this is the formula for the LSD value if you want to carry out your post-hoc test for post-hoc. Alright. So, but mind you, you also have to conclude before you do your post-hoc. We forgot to talk about the hypothesis. Let's also talk about the hypothesis for treatment and for block. So we talk about the hypothesis for treatment and for block before you start to compute. That was what we missed out. Then, after accepting the alternative hypothesis, you now state the hypothesis that you have stated before. Right? You restate it as your conclusion. And then to carry out post-hoc, we said the formula changes to this. Initially, without missing value, you would not have to correct the bias. But now you add C into bracket MS7, the same MS7, open bracket over R minus R into bracket R minus 1 and C minus 1. Alright, that brings us to the end of the video. Please do well to subscribe to the channel. Thank you.